In this question, we want to find how many 3-digit positive integers have a remainder of 2 when divided by 6, a remainder of 5 when divided by 9, and a remainder of 7 when divided by 11. What we would do is we would use modular arithmetic for this problem. So let's let n represent our 3-digit integer. And we're given it leaves a remainder of 2 when divided by 6. So in terms of modular arithmetic, we can say n is congruent to 2 mod 6. And we're also given that the number leaves a remainder of 5 when divided by 9. So we know that n is going to be congruent to 5 mod 9. And we're also given that it leaves a remainder of 7 when divided by 11. So in terms of mods, that'd be n is congruent to 7 mod 11. So what we can do now is basically rewrite. We can kind of rewrite these 3 congruences. So you can write this first one as n is congruent to -4 mod 6. I can kind of write this second congruence as n is congruent to -4 mod 9. And I can write this last congruence as n is congruent to -4 mod 11. And the reason this is helpful is whenever you have mods, a system of congruences where these 3 numbers, or not necessarily 3 numbers, these inside numbers here are all the same. In this case, it's -4 for all of them. So this is helpful because we know that the smallest number that is a multiple of 6, 9, and 11 is just the least common multiple of 6, 9, and 11. And that is just 198. Yeah. So we know that n is congruent to 0 mod 198 is congruent to 0 mod 6, 9, and 11. So yeah, so we have 198 is congruent to 0 mod 6, 9, and 11. So we could just subtract 4 on both sides. We have 194 is congruent to -4 mod 6, 9, and 11. So we know that 194 is the smallest possible value. But remember that the question didn't ask for the smallest possible value. They asked for how many positive 3-digit integers are there that satisfy this. But notice that it kind of repeats every 198. It's a cycle, right? So if I have 194 plus 198, this also satisfies the conditions. You can plug it back into the congruences and check it. It'll work. And similarly, 194 plus 198 times 2 will also work. 194 plus 198 times 3 will work. 194 plus 198 times 4 will work. Just basically 194 plus the multiples of 198. And then if you go on to 194 plus 198 times 5, it turns out this would be over 1,000. So that's no longer 3 digits. So it turns out we only have 5 possible values here. And that would give us choice E, 5 possible values.